Okay guys, this is the first video, I think it is the first video for circles that we're going to do. We'll probably go through a bit easy with all these circle terminology, but there are some words that you really need to know, and you can find them in your textbook. This type of question is an example where we need to know exactly what certain words mean. I've underlined pretty much the three keywords in this question: center, radius, and chord. So, the point O is the center of the circle, with a radius of 34 centimeters, so 34 there. And OP is perpendicular to AB. Now we don't know if P is a point on the circumference of the circle or not, so we might not write OP just yet. If OP is equal to 16 centimeters, which means that it is definitely not the radius, find the length of the chord AB. Okay, so the fact that AB is a chord means that it goes from one part of the circle, one point on the circumference to another point on the circumference in a straight line, which I could probably draw like this, going across. Oop. There we go. Alright, so if OP is perpendicular to AB, I would assume that it would intersect over here. Alright, so for a few things that we need to know about chords. Any line running between or perpendicular to a chord, or any line from the center perpendicular with the chord, creates isosceles triangles pretty much. One isosceles triangle. It looks a bit like this. That down there, that down there. That's our iso triangle. Now if we're trying to find the length of the chord AB, and AB is from there to there, it's pretty simple. It's just a matter of us applying Pythagoras' theorem. So this length over here is 16 centimeters, which means that we can look at the question from this point of view, and I'll do the same colours as I did in the question. We had a thick black line over here and a thinner black line over there. So let's just say this is the point A, this is the point O, and this is the point P, because the point over here is P. The values that we need to fit in, this is 16, and a little bit of information. If I go back to the circle, going along here, this, and this, what are they? They are radii. So it might be a good idea to draw lines like that there. Okay, so that means that this length over here, going along here, is the same as this length, which is 34. Okie dokie. So we can find the length of AP pretty easily. AP squared is equal to, that's going to be 34 squared minus 16 squared. Please remember guys, the reason why I'm subtracting one square from the other square is because the hypotenuse is known. Now you need a calculator for this question, so 34 squared minus 16 squared, that gives you 900. 900, which means that AP is equal to the square root of 900, which is 30. Okay, so remember that the question is asking us to find the chord AB, and remember that we have I'd said that this was one isosceles triangle, and that's right. However, it's probably better to think about it as when there's a line that goes through the origin perpendicular to a chord, it creates two congruent triangles. So you can see here's a common side. These two sides are radii, therefore equal. And whenever we have a right angle there, well, the reasoning behind that, the proof behind why AP is the same as PB would be side, hypotenuse, right angle, or RHS. Anyway, we can write there AB therefore will be equal to 60, and all of these measurements are in centimetres.